welcome to the last session of the zkSummit 8. We are going to do the park bench panel. This is always an experiment. It's sometimes a little messy. And as I said, it's really important that you prep your questions. Without questions, the thing doesn't work. So I need you to have some hot takes and good questions. So I think we often use this time to also talk about somewhat controversial things. And so I think our first question that we wanted to talk about was, what is zkEVM and what isn't zkEVM?
Intro round.
Oh, intro round. Oh, good idea. Okay. Let's start with there.
I'm Zucky. I work on a variety of blockchain projects. I have something called Sommelier Finance. I've been working on a thing called Cosmos for a long time. Some people have heard of it. And that's what I'm here for. I don't know. I've been a ZK fanboy for a very long time, and that's how I think I ended up on this panel.
I'm Henry. I work on Penumbra, which you may recall from the previous talk. So yeah, we're building a private DEX, I guess.
And yeah, I'm Alex. I work on Aleo, also a longtime ZK and ZK podcast fanboy, which is probably also how I ended up on this panel.
Okay, I'll ask the question again. What is zkEVM and what isn't zkEVM?
So, there's I will frame this thing so there's this 4 kinds of zkEVM blog post that Vitalik wrote, which is an attempt to systematize this actually very difficult question, right? Because it basically anytime anything happens in zkEVM, and the last big zkEVM thing was Paris, Polygon comes out with we've made a zkEVM and everyone else's zkEVM is not a zkEVM, and then everyone else with the zkEVM says all their other counterparties are also not zkEVMs. So this does seem to be a little bit of a kind of a Mean Girls kind of thing going on, where you're either in or you're out, and the in-group is being the one true zkEVM. I think one of the biggest challenges of this is that zkEVMs are right on the cusp of being turned from being research projects into something that you can tangibly sort of understand end to end and build upon. And it's going to be probably the ultimate question, I think, is you will know a zkEVM just so this reminds me a lot about when people were building the first proof of stake EVMs, and it was there was are you bytecode equivalent? Are you RPC equivalent? All of these things. There was this huge conceptual framework, and you know what actually mattered? What actually mattered was if the developer community could adopted your thing and decided that this was good enough for them, and so EVM equivalence ended up being very much this good enough question in the BFT proof of stake setting. I think the same thing will apply in the zkEVM setting.
I have no skin in the game, so I don't know. To me, a zkEVM is something that somebody makes, and they write a blog post about here's our zkEVM, and they explain what it does, and then people can argue about it. I don't know.
Hot takes. Also, if anyone makes a meme of Mean Girls with all the names of the projects above the characters, bonus points. Yeah, so I guess I don't have much to add. I think Saki gave a great answer. My quick take, I think, is that in general is kind of the lower down you try and achieve EVM equivalence, it seems like there's a performance trade-off, or you have to kind of make compromises in certain things. That was really the thrust of Vitalik's post, I think, and I think that's kind of what we've observed with the different zkEVM implementations. And so I think it really comes down to the community of people around this that will end up adopting something, and they'll really decide at what level does it matter if you're down to the bytecode compatible, or if it just okay, if it's fine to at a higher level, if that compatibility is okay. Of course, Ethereum has huge network effects, right? They have the entire ecosystem of dApps. They have a whole ecosystem of Solidity developers, people who are familiar with that model. And so I think that's why people try and really closely hew to it. But I think potentially there's a lot of really interesting constructions coming out that are much more performant. different ZK VMs that kind of give you a big performance boost, which potentially will, I think, over time, you'll see people building on those ecosystems, and we'll kind of get I think, probably a diversity of different VMs or ZK VMs that serve kind of specific use cases.
Can I pivot the question a little bit?
Sure.
Okay, so maybe to make this question more relevant to the people who are on the panel, Henry has this like sort of half-baked maybe VM idea, and Alio has a more baked VM idea, but neither of them are emulating anything with existing network effects. And you're like trying to restart your own network effects, and we have lots of people who are here, whether it's the ZK EVM people or the Risk Zero people, who are trying to take advantages of the network effects of something that already has network effects. How do you think about that?
So I think, my opinion is for any new protocol or product, you have to differentiate and offer something that is unique and new. I think I hear a lot of time because so Alio, we're building our own language called Leo. It's a high-level language that compiles down to an IR Alio instructions that then gets rolled into R1CS. So it's kind of a new ecosystem that developers have to learn to build in. And I hear a lot of times they're like, oh, well, who wants to learn a new language? And I actually don't like that question, because I think everyone in this room and most developers I've ever interacted with, if something adds value to what they're doing, if they see something as legitimately interesting, they will absolutely learn it. Look at Rust. Rust is a new language, right? So most of the projects today in this ecosystem certainly use it. So people thought Rust was interesting and useful enough and provided some value such that, okay, they're going to go ahead and use it. And so I think it's really just a matter of, of course, on Alio and every project that's starting from the cold start, you have to figure out, okay, how do I want to be different? I think that's really the starting point, is how do I want to be different, and what's the value that I can add? Maybe that you don't have to say it's better than Ethereum or worse than Bitcoin or whatever, right? You don't really need to compare it in that way, but I think it's what is fundamentally different. What can you do in this world that you can't do anywhere else? So that's how I think about it.
So I guess maybe I'll say a bit about how we think about network effects, and then segue into sort of ZK VM generally. The strategy that we have is basically, try to build one useful application, and try to have sort of a very, very narrow initial scope, but build something that is just like genuinely better because of the privacy features that it has. So we're not actually trying to build some kind of like programmability thing. The talk that I gave about like, here's an idea of how you might do that is really just an idea that is a possible generalization of the concrete system that we're trying to build. And so the overall strategy of Penumbra is like, okay, how do you build like a DEX that's better as a DEX because it has these privacy features? And then once you do that, you're going to end up with a bunch of users who are using the product because they're getting some kind of value out of it. And once you have that, now you have some kind of audience that might be interested in interacting with some kind of future programmability system once it exists, right? And so that, I think, is a different kind of network effect. It's a much more direct, like, let's just build like one thing, rather than let's try to build some kind of environment where other people can then build a thing. I think that if you get that to work, it's like obviously much more powerful, but also it's a much harder lift as a project, because now, for all of these other people who are going to be writing applications, you're just kind of like another project, whereas whether they do or don't do that, for you as a project, that becomes this kind of like life or death thing. The second point on kind of ZK VMs generally, I think that the existence of really any kind of ZK EVM is just a really incredible like technical tour de force as a matter of like snark engineering. However, having to have compatibility with EVM bytecode is not really just about the bytecode. It's about the state model. And my personal belief is that like the state model of Ethereum was like designed to be a like transparent system. And when you try to make that private, it's not just a matter of like, oh, well, we'll make all the we'll like snark all the state transitions or something, but if you have a notion of privacy, you have a fundamentally different data model, because now you have different entities that are supposed to have access or not have access to different pieces of information. And so it's not, to me, it feels like the programming language or the bytecode or whatever is actually this like, second order, like downstream thing of the more fundamental thing of like, what does it mean? Like, what is the data model for like private computation on chain, right? And for example, with Aleo, there's, you can effectively have sort of like every transaction be its own little like micro rollup or something. For us, we're trying to focus on like, how do you have interaction between like some like public computation and some like individual like private data, and try to have some kind of differential privacy or something there. But I don't think that it's like really clear what it actually means. I mean, in the sense of like, I have my opinion, but that's not the same as like a market validation, right? And I guess the concern that I have is that if you start by saying like, okay, we're going to take the path dependence of Ethereum and then like make it ZK, you may end up like sort of paying an enormous amount of cost to do all this like complicated proving, but then it's like, great, well, now we just have this like centralized sequencer. So, what was that?
Cool. All right. I want to see, do we have another mic? You have a mic, right? Are there any questions, comments, ideas? Oh, there's one arm right up there. All right.
I feel like someone who actually makes a ZK EVM should like
might want to weigh in on this.
Might want to weigh in.
Can you make sure the mic is on? Sorry, just give it a second. What number is that? There we go.
Oh, now we're here. Yeah, I regret I was not on the panel when the question was asked, but
well,
but I can still give my answer.
You might be up here in a second, so.
It's interesting that we're using in ZK EVM. We're actually not using the ZK property properly, right? Like it's not for zero knowledge. It's standing for zipped with cryptography to use the succinctness to scale computation. So you can think of it as like just computational layer, just like IP protocol is for data and SSL protocol on top of that is for privacy. Similarly, we can build protocols on top of ZK EVM that provide privacy. My question is about privacy because you guys are working on privacy mostly. And it's going to be a controversial question, of course, like a spicy one. So,
hot takes.
We see an attack on privacy happening recently with Tornado Cash being put on our FAQ list. And it seems like a systematic approach. Like it's been boiling for a while with elliptic chain analysis, like the soft censoring of transactions by exchanges, and now like straight on attack on the privacy protocol. How do you feel about the path of development of these regulations? What can you share about your ideas? Like, how do you see the space developing? Like, is it going to affect all the privacy protocols? Do you expect like compliance? Do you expect non-compliance? Like, how you think about the situation for the future?
Okay, we're going to have you come up, but first, why don't you answer that question? You're going to be taking Alex's spot. Alex is going to switch for Alex. Keep it easy.
That's good. We can just roll. There's enough Alexes
Only
in this
Alexes
room. We can
are allowed
just
to
fill
sit
this
here.
chair all day.
All right. Go ahead.
So I can take a first stab at that. So first of all, I think the OFAC regulation, or the action against Tornado Cash that you referenced, I think there was some news yesterday that I thought was encouraging personally, where they laid out a path where, okay, if you had interacted with that contract, you could potentially clear your name effectively by going through some process. So I think the process that they proposed was a little bit burdensome and may not really be what I hope we end up at, but I think at least now there's some understanding, a more pragmatic understanding from the view of the regulators. Now, I think my personal belief with existing decentralized systems today, let's call them Bitcoin and Ethereum since those are the two biggest, is that model is so much more radically transparent than the existing financial model of banks that I really think that it's going to be difficult to, if we imagine a world in which Web 3 overtakes Web 2 and Finance 2 overtakes Finance 1, I think without without stronger privacy guarantees than those existing systems offer, it's just not going to have people adopt them. I mean, I think look, I think we have to be honest with ourselves on a lot of the volume that happens on Ethereum. You know, people do DeFi and they do NFTs, and I think a lot of people view that as fun and interesting and cool, but very few people, I think, are getting their paychecks there. Very few people are doing what I would consider real economic activity. And, you know, if I send Guillermo one USDC on Ethereum, not only do I know his entire bank account effectively, but everyone who's ever interacted with him and their entire accounts. And I think that model, like, to me, that just seems like to be a fundamental blocker for adoption. Now, I think you raise an interesting point where do you need to bake everything in one layer where you have privacy kind of guaranteed all the way up, or can you separate it in layers? I mean, I think there's legitimate points on either side. I mean, obviously, Alio's taking the approach from the bottoms up because we think that gives you the strongest, most unbreakable guarantees there. But I think, you know, it's really interesting to see how this ecosystem evolves. But overall, I guess the last thing I'll say is I don't think any of us can escape the need to be compliant at some level. But I think what we can do is advocate for, and the best way we can advocate for what we're building is proving they're useful. Right? And that's why I really like what Henry said a minute ago, where it's like he described privacy as a feature of a product that people actually use. Right? I think this is something that I don't think we as an industry focus on enough. It's like, hey, let's really talk about like how does this matter to some consumer, right? What's the consumer-facing product, and then building back from there.
I mean, one thing that I think is just like interesting about this is like there's some regularity to transactions on Ethereum that I control, like sort of making, paying invoices and stuff like that. And they're like, the attempts to hack me are directly correlated with like the regularity of those payments. So basically, like, I feel like this is like kind of like the most practical thing that I've been seeing as like exposure to is like, oh, like the attacker sees that like typically we pay invoices around this time of the month, and then like spear phishing is just like pervasive like that time of the month, which has been an interesting exposure, like privacy exposure, and I think potentially a good articulation of like why that might matter. I think also Henry has like a really good rant about like how IBC is a good mitigation against these things, which I'd like to hear.
Wow, setting him up.
All right. I mean, that wasn't what I was going to lead with, but sure.
Set spike.
So I think, yeah, like there are some good comments on the kind of like regulatory side, like explaining like the value of privacy or whatever. To me personally, as a builder, the thing that seems like the most useful thing to do is to build products where the privacy is like clearly this kind of core enabler of what that does, right? So for instance, if you're trying to have like market making on chain, and somebody can just like open up a block explorer and see like who are the top 10 performing LPs, and I'm going to build an index out of their strategies, like effectively you cannot do like good market making in that kind of environment. And so if you build products that just like are better products because they have privacy in them, I think it's just a much better place to be, both in terms of like having a larger user base and a kind of like more tangible near-term argument for why it's important. I guess, yeah, on Zaki's sort of like, request for comment, I think the existence of IBC makes the type of censorship that was done a lot harder because all of these different sort of chains just communicate with each other permissionlessly. There's not some kind of particular set of, this is like the address of whatever. Like you'd have to like block entire chains or like entire bridges, right? And so I think there's like a lot more collateral damage if a censor was trying to, put a stop to like some particular thing. I also am not really sure that tornado cache OFAC designation was this like carefully calculated like next iterated step in this like big long game or whatever. Like to me, it actually seems like a kind of like ham-fisted, like, you know, someone told us that we had to do something about this thing, and this is something that we can do. You know, like if you look at the actual law before that is supposed to give that power, it talks about like sanctioning specific persons. So like, I don't know, did we accidentally like grant legal personhood to a smart contract? Whoops, I don't know, like that'd be a kind of funny implication. But none of this really seems to be thought through. Like the fact that there's like viewing keys where you can like see exactly what your account activity is and like demonstrate that to some third-party auditor. Did that matter? I don't know, apparently not. So like, what's the point of trying to like build a system that has regulatory like capability built in if the regulators don't really seem to care?
I thought it was interesting that like with this license thing that got announced, they did not ask for the viewing key. It seems like that would be like the logical step in like getting a license as a US.
Again, to Henry's point, I mean, this might just be ignorance on the part of some of the bureaucrats who wrote the rule. I mean, I think there's often, and speaking as someone who's worked as part of a U.S. government bureaucracy before, I mean, it's oftentimes, you know, people like to think of it as like the Illuminati, but sometimes it's a little more like Office Space, and so, you know, so I think, yeah, these things will evolve. But I guess, and I know I need to pass the mic to Alex, but the last thing I'll say is, you know, look, I'm actually really optimistic about this. I mean, if you go back in the history of cryptography, I mean, I think we've made enormous progress. I mean, there was a time when the fundamental cryptographic algorithms that we all rely upon were export controlled. They were like, and it was like illegal to take them around the world or like tell anyone about them, right? There was a time even more recently with crypto, like there was legitimate talk of would a government ban Bitcoin or ban this stuff? And I mean, that's at this point just seems so remote as to be ridiculous, you know. And I think we're kind of on this next frontier of this technology. And, you know, I think it's, of course, like early days. It's too early to say which way it's going to go, but I think there's a legitimate path for it to become accepted and legitimate and welcomed even by institutions and governments. So we'll see.
Cool. Thanks, Alex. Come on up, Alex.
Alex, tap in.
All right, do a quick intro. Alex G. Let us know who you are.
Hello, everyone. So I'm co-founder of Matter Labs, which is the creator of zkSync, the first ZK EVM.
The first.
All other ZK EVMs are not ZK EVMs, right? Not just the first, the only.
No. We were the first to introduce the term, the first to implement the prototype, the first to open the testnet, and we will be likely, hopefully, the first to hit the mainnet. But the others are also ZK EVMs, of course.
All right. I want to open the floor. Are there any other questions? Anyone who might want to weigh in on anything that's been talked about? And I will wait. We do need questions for this to work. Comments, thoughts, anything?
Considering that we now have a variety of trustless setups, my personal preference recently has been bulletproofs. What's the continued justification for deploying new crypto systems using Graph16 and other trusted setups?
That's opinionated.
You said hot takes.
Yeah, hot takes gets up. Although bulletproofs doesn't have a trusted setup.
He said trustless. I think he said
trustless
setups.
setups. Okay,
no
okay.
setup.
Oh, got it.
Yeah, I mean, like, the setup is like one engineering axis out of like, you know, a dozen or whatever, right? Like, personally, if I don't, this is just my opinion, right? But I think that if you have a situation like, say, like the sapling ceremony, I actually really wouldn't use the term trusted setup for that. I would say that's a decentralized setup. And I don't think that there's really a meaningful technical risk there compared to, say, like, oh, I wrote the circuit wrong. I like didn't constrain something. Whoops, there was an inflation bug. Like, whatever. Like, those all seem like way bigger risks to me on the security side than, you know, 299 out of like 300 participants were all collectively dishonest, and like there's like, you know, the one holdout that they like wrench attacked into colluding with the attack or something. Like it just, and then the other thing that's nice about Groth 16 is that like it has like very good constants. And if you look at like I think in practical terms, like who is the marginal user of some privacy system that is like, you know, I would be using the privacy system, but it has this like setup. Like I think that much more important is like what is the actual performance of the system? How does it work? Like for Penumbra, for instance, like it's actually pretty important that you be able to do the proving quickly, because you want market makers to be able to respond to price information with reduced latency, and you also don't want them to be on this like separate sort of transparent thing, because the point of like the whole game plan for Penumbra is like you use the market making to bootstrap the privacy set, right? So then actually having performance is like kind of probably also like directly important for privacy. So I guess like what I would say is like there's a lot of different engineering axes, and I think that like the specific kind of security of having a setup or not is like not that high on the list. There's other reasons why you might want to like a universal system, but I think not for security, in my opinion.
Well, the obvious answer, like on the surface, is that it's a lot cheaper to verify Groth 16 on Ethereum, like on the system like Ethereum, where it's quite expensive. So like Groth 16 verification costs around 300,000 gas. A full Stark verification is currently at 5 million gas. That gives you a lot of like 20x, almost 20x, like 18x difference. That enables you, for example, to do more frequent checkpoints, because you need to amortize. You need to wait for enough transactions in this batch that you're rolling up, if you're using it for a rollup, for example, to justify making this checkpoint and verifying the proofs. So it would be great if if Groth 16s are going to be used still in the future, that they are made as universal as possible, that they are just approaching, like targeting a certain proof system where the parameters, the verification keys are passed externally as inputs, so you can reuse it many times, which gives an incentive so for many people to participate in the ceremony and make it more secure. But over time, for like in the long run, I think that we'll absolutely have to avoid doing trusted setups. You cannot build the internet of value, especially with privacy, that no one can actually see inside and check that it's still keeping integrity on something which like depends on 300 people. Like no matter how legit and prominent those people are, like to have institutions move to crypto and move all of their transactions there, it must be completely transparent, and that's where we're coming to in a few years, I think.
Oh, seems fine. Like, you just like make the setup bigger. Like, I don't know. I think that there's not like one of the things that's cool about Groth 16 is that because you actually have a hard-coded statement, like the wiring is free. So that's kind of like a fundamental thing that is cool about that from a performance standpoint. And I don't think that goes away. Like, I think that the solution is just that we like get good at doing setups, which is actually what's happened, right? Like comparing the trajectory of like the first like Zcash setup to the sampling ceremony to like all of the ones that are currently ongoing. It's like, okay, this is like a thing that it's like a collective coordination problem that people who build the coordination technology like get good at coordinating. I don't know, cool. Seems fine.
I don't know, like every ceremony requires a lot of attention, a lot of diligence in like how you actually prepare your machines for that. Like you might have 300 honest participants, but all of them, for convenience, just used some software that they download from this link that the participants, the organizers gave them, or they participate from a browser app where they do everything in browser, which is like, like you want a lot of different eyes, a lot of different implementations.
I agree, but I don't think that that's actually a problem with the setup. I think that that's just a fundamental problem with making a circuit. You also have to get the circuit right. You have to have assurance on that. What happens if somebody puts some kind of subtle bug door in the constraints that allows
that is transparent. That is auditable. You know it. There is a chance that people will discover. Here you can do it theoretically, fully covertly, and not letting anyone know. And this is especially problematic in the context of private systems. With open, transparent systems, we will at least notice that, if something happened in zkSync with Plonk, with ignition trusted setup, it would be obvious that the setup is compromised. But with a private system, it would not be obvious. There can be things that go wrong and no one knows, right? Like some hidden minting of assets, etc. So, I think for wide use of privacy, we really want transparent systems in the future. But that's not an urgent problem.
I think we're gonna move on, if that's okay. Henry, I think you're off, and I think you're on. Thanks for being on here, Henry.
And I have to be on a Twitter Spaces at 6, so you gotta get me off this.
You have to get off soon?
By 6.
You have 21 minutes.
I have 21 minutes.
Okay. Do you want to introduce yourself?
Sure. Hi, I'm Luke, also known as Kayaba online. I volunteer around Monero, and then I have my own project as well.
Nice. All right, are there any questions, comments, thoughts, anything on what was just said? Alex, there's someone right there.
Oh, sorry.
Could someone describe what is the difference between schemas based on inner product argument versus the existing solutions? I mean, the trade-offs.
So that's a question. So that's not an opinion. So yeah, I think.
So the question is, can someone describe? My answer is, I'm not sure. I can't.
Did Benedict already leave? I was going to say.
Can you say it again? Describe the difference.
Inner product argument, which is the pasta curves.
Yeah.
In Zcash. They have a way to do this without trusted setup, but apparently there are some speed or performance trade-offs, which I'm not aware of. Maybe someone knows.
Yeah.
What is this?
There was an episode I did recently with Halo, Dara, and Strad, and we talked about that, and I don't remember. So you can listen to it.
Yeah,
I think we talk about something like that.
That was what I was thinking about when listening to this question. I think the trade-off is what, inner product stuff versus KZG. It seems to be the current trade-off space of people who are building these general purpose protocols, but I am not the person to try and explain this either.
Cool. All right, any other questions, comments, ideas? Back there. Nope, there.
I guess my question's a little bit pointed at zkSync. Seems as you're up there on the stage, I get to ask you a question. It's really cool what's happening with the ZK EVMs, but do you think there's more of a fundamental architectural kind of a different approach you could take rather than, because right now with the EVM contract, the state has to live effectively on a single machine, right? There's a capacity to how big the state can be, right? And so is there a thought into the direction that could go into expanding that into a different kind of architecture as opposed to something like EVM? I know there's obviously shards and stuff, but ultimately the data still has to fit in a smart contract. Because with zkSync right now, I understand you put all the data back onto Ethereum, right?
So there is no fundamental limits on how large the state can become and how we can process it. We could use some parallel transaction processing techniques to like like prepare the block before it's being proven, and proving always happens in parallel. We can parallelize all proving really well. So it's not really a question of how you structure specifically ZK-EVM, it's just how you build your blockchain in general. One thing that ZK-EVMs can do differently from Ethereum is actually diverge from Geth and the existing Ethereum clients that are optimized for the broader usage, like for having a lot of full nodes run on consumer hardware, on ordinary laptops, and build special clients that are optimized for being run by validators, where you have higher requirements, where you can say, let's keep all of our state in memory. So it's going to be a lot more expensive, but like in the context of having only like a dozen of those validators actively running the consensus, it can be a good trade-off. And this is what we're doing. Like, we're not using Geth. We're building something that will be potentially more efficient than Geth as a full node. But that's not specific to ZK-EVM, in my opinion.
Do you have any thoughts? If not, he's going to take your spot.
Cool. No, because the sacrifice is accepted.
Okay. All right, come on up. And thank you for being up here, Zaki. And I hope you make your call. All right, here's a quote. Oh, wait. Any questions? Throwing it out there. Okay, there's somebody there. You're next.
Hello, guys. So after DeFi 2020 and NFTs last year, I think now it's a comment for me, of course, but I think it's identity season.
Oh.
And how can we leverage zero knowledge to protect identity of oneself on the blockchain? Do you have any thoughts on that? And
Sounds like a comment.
Yeah, comment / question.
Is your name Alex? Because you have to be named Alex to sit here.
My name is Alex.
Okay. Is it actually?
No, it's not.
Oh, damn. I thought we were on a roll.
Gotcha.
Okay. It was 80% chance. Okay. Does anyone want to answer the question about ID, ZK ID, or ID on the blockchain?
So this isn't really my field, so I may sound like a total idiot here, but I'm going to try my best. To put this kind of in Monero terms, I'm not here to shill it, it's just the best way I understand it, and if I'm going to give my best answer, I have to rephrase the question a bit. There's talks about a transaction protocol, and one of the things it's doing is it's working towards, I'm really not trying to shill Monero, I'm just sorry.
Oh.
But my point is they're taking a public key, just as we all know them, except this public key is actually the aggregate of multiple public keys, each for their own purpose, and because yada, 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 discrete log problem, you can't change any of the individual public keys. You have to have them all correct together. And when we're discussing decentralized identity, I think the simplest way you could implement such a system is simply by having an aggregate public key. You can say, oh yes, I have the public key that says I'm a US citizen, because it's not actually a public key, it's just a point. And you're just saying, yes, the point that says I'm a US citizen is in my public key, which is what I'm using for decentralized identity. But you can very quickly and trivially create a circuit, whether it be Graph16, whether it be some bulletproofs you're running on your computer, whether it be a Halo 2 instantiation, that just blinds it. It doesn't actually change any of the value that you've embedded in the point. It just says, hey, previously I was using this value, but I know some offset that lets me transform it. So an app doesn't need to know who I am at a base level. It just needs to know I have appeared as this new static identity, and I have these properties in my public key. And obviously that doesn't solve the problem where you have multiple people creating IDs, yet you can also use ZK snarks to say, yes, this offset is derived from a very specific process, and because of that, I'm not replacing it with anything else, but even though I'm creating it with this specific process, it's a snark. You don't get to see how I did it. So part of me wonders why decentralized identity hasn't done better, because I feel like when I try to describe it, it's very simple, and that's probably why I don't work in the field, because I'm missing something. But that's my attempt at a stab at it.
Cool. Any thoughts? ID?
Yeah, no, I agree. I think it's going to be even one of the next big things, because when I'm asked to like log in with Ethereum with my address, or like receive POP NFTs on my address, and like also attach for convenience the ENS name like with my handle to this address, it's getting weird, because like now you're logging in, everyone knows who you are, everyone knows where like all the things you've done, where you've been, with all the NFTs, with all like, you know, like all the like and tickets to some events that you purchased. It's strange. So you really want to be able to connect in a way, you know, like this Apple ID is connecting you, like which is implemented better than Google ID, because it creates a like unique email for every app that you're trying to connect with, and it only shares this like random pseudo-random or like pseudomized ID to those things. Totally, and it's actually not that complex to implement. So it's a matter of good UX and a standard that everyone will accept. So this standard question is problematic. You can think of this XKCD crypto standards.
Yeah, I think that's the problem in general, is coming together on a standard that everyone agrees on. And I think identity suffers from a usability problem too. And so when it suffers from a usability problem, you basically just get MetaMask installed in everyone's browsers, and that's it. And you know, it's there's 100 different wallet providers all trying to break into this market, but ultimately everyone's installed MetaMask now, so it's very challenging. So obviously, as an industry, we need to grow, and we need to obviously keep working on these new technologies. What I would say is, I think we're missing a layer of, and it was really interesting. I think one of the other speakers talked about creating something of actual value for users, because that's what makes them install a new browser extension. Yeah. That's what gets them to drive change. That's what gets Brave installed instead of Chrome. And I think we need to think a lot more about what technology, and you know, so I'm the founder or co-founder of Spacetime. We're building a decentralized database, and one of the things that we're really passionate about is rethinking the whole model. So yeah, I won't go into it.
Yes,
but
I think I forgot to do an intro to you, hey? Oops. All right, Alex, switch with not Alex. What's your name? Let's find out who you are. And we're going to do another question in 1 second. So thank you, Alex, for being on. And welcome, person who does ID. What is your name?
Alex. My name is Miguel.
Okay, different name. So just introduce yourself real quick.
Yeah, my name is Miguel. I'm working on a lot of open source software like ZK infrastructure and the game. Yeah.
Cool. All right, any more questions, ideas, comments? I think I saw a hand right there.
Hi. So, well, it depends on who you ask. A strong argument against switching to digital voting from ballot voting is that the ballot voting process is it's leaky, it's faulty. It's not so has other faults, but it is auditable by everyone. And going to like a digital voting scheme would require a very sophisticated one that then puts this into like an oligarchy that can then that is then the only set that can actually verify that this was done correctly. Now this argument has a risk, a slippery slope that it can just become anti-intellectual, but I do think some of this applies to the question of let's skip out privacy for now, but like using ZK for scaling. If you go for this kind of complicated technology, you could also just be waiting for technology that is much simpler for scaling than using zero-knowledge technologies to achieve this, which is kind of the tendency that Bitcoin has. So my question here would be, like, what is your view? Does this apply to zero-knowledge technologies as well?
What?
Like this argument, should we replace, just for the sake of scalability, replace systems like, for instance, Ethereum that are much easier to audit by a broader set of developers or eyes than something than technologies that have a much more restricted set of eyes that can actually audit it?
Should you replace ZK? Just say the question again?
Yeah.
I couldn't
So
quite
like,
get it.
are there cases where you would say, ZK shouldn't be replacing this technology because the other technology, while it is less efficient, is much broader, can be audited by everyone.
Okay.
Say, for instance, Bitcoin.
Do you have any answers on that?
I can give it a go.
Go.
So I think what you're asking is there a downside to privacy, and is there a downside to making things zero knowledge so no one can see what's happening, right?
No, not quite. It's the technological implementation of that. So how complicated the implementation is to audit for a broad set of eyes.
Oh, okay. So
like in the same way that like ballot voting, like anyone can like check that very locally in their district ballot voting was done correctly.
Yeah, well, I would actually argue that how many in here have audited a Ethereum smart contract themselves? Or how many times, have you done it 100% of the time for every smart contract that you've used? Probably not. I think it's really unrealistic to think that everyone's going to audit every single contract that they use. And so actually, I think this is one of the things that we need to look at in Web3 is, okay, how do we make it, easier for people to look at a smart contract and understand what is it doing? And there is obviously an element of trust here, but you still have to trust that, the web dApp that you're using is still using that technology and not actually going, oh, actually I'm going to use this other contract. And obviously there's things around signing, but again, how often do we check the contract key, that we're signing away from? So I think one thing that we rely on today is the fact that people can audit, and people do audit this technology. And I think that won't change because it's ZK technology. I think, in fact, really, the fundamental thing will be we'll still have the same problem that we have today, which is we have thousands of different circuits or programs that we need to find a way that people can audit them easily. And some of those, there are ways around this, right? Rather than having the developer to be able to change everything and write very explicit code, can we create some sugar syntax to say, okay, if we're transferring from X to B, do you really need custom code to do that? Because if you have custom code, you can sneak in some stuff. Like if you've looked at the OpenSea smart contracts, they have a God clause where it's like, oh, if it's OpenSea's key, you can just do whatever you want, right? And so these things exist because we allow people to write custom code. So I think, yeah, that's probably my answer.
Can I just add a sentence?
Sure, go for it.
I was just going to say that I think no matter what protocol we discuss, there's going to be a few different numbers to look at. There's going to be amount of people who would like to audit it, but don't try to, amount of people who try to, and then amount of people who do. And I think if we throw ZK into the stack, the amount of people who will try to in any decent matter will immediately go down because they'll shut off, they'll realize it's not for them. And, well, yes, we can dream of a future where it's automated. We do have to consider if we practically want to get more developers involved, we have to promote a level of accessibility. And anytime we pick a more complicated protocol, that's obviously going to be a trade-off. It's decreasing the amount of developers who can participate, but it's gaining us efficiency. And no matter if we're discussing ZK or not ZK, if we're going to get more efficiency, we're always going to appreciate that.
Yeah, just to conclude, I think it's always a trade-off between education and design options. So we have to figure out what's the best option for each case, and yeah, that's it.
Are there any questions, comments? Anyone else? Let's throw it out there. You had your hand up. What happened? No? Oh, you can bring it back. You can actually bring it back to any topic we've talked about today. It doesn't have to follow. This is a very fluid format.
Oh, this is going to be even weirder, actually.
Okay.
This is really, actually, I think it makes sense for ZK audiences. I'm going to really put my tinfoil hat on.
Okay.
And ask the question, what happens if one of the cryptographic assumptions that we have for a lot of these ZK protocols is broken? On the auditability process.
Ooh.
Like, how do we know? How do we know? How do we know that this isn't like another NIST debauchery where you put in specific numbers that happen to be surely random, but probably end up having a backdoor? How are we sure? And do you trust yourself on that?
Wow, hard question.
Okay. Well, you're going to come up just because you're going to come up, but I don't know if you can answer this question.
Well, a lot of the ZK technology is based on the encryption that has been proven out. So I would say it's not just this magical new thing that we've decided, oh, we're just going to try this. But of course, as you mentioned, there is concern. And I think that's why we need more people creating these different types of algorithms rather than taking them from the government, which is definitely not a good idea. We could maybe take them from a broad range of researchers and have more auditing done. And I think that's really the only way. And ultimately, SHA-1 was broken, right? So we need to be aware of that as an industry and be ready to move to something that's safer and something that's better.
Is this true, actually? Because there's a bunch of weird algebraic assumptions that we make for a lot of the ZK systems that we have.
Go on.
But anyway, sorry.
I think it really depends on what assumption you want to talk about. If you want to talk about the discrete log, like, well, if that's broken, we have a lot of things going on tomorrow. Personally, I'm waiting for P equals NP hard crypto to come out. If someone got that, let me know. But then, of course, we have a variety of other assumptions. We have discrete log, sure, we trust that, we rely on it every single day. And then in threshold signatures, I believe one security of model of Frost, which I cite just because I also have worked with that, is premised on one more discrete log, which says if you know a bunch of discrete logs, you still can't find another. And as a non-academic, that kind of just sounds like the discrete log problem. I don't get why it's a different assumption. But obviously in academia, we constantly have these new assumptions. What I think it's important to look for when we're discussing ZK proofs is, one, that they're actually formally proven, have gone in review, but two, my big red flag is when they introduce new assumptions, because that either means they're revolutionary or you should be running away as fast as possible. To circle back to Monero, just because that's what I'm familiar with. I have a frame of reference, okay? We were excited.
He's a Monero guy, for sure.
Thank you, I appreciate that. We were looking at this one protocol called Triptych. It was either Triptych or Arcturus that had this property. I think it was Triptych. And it was based on I think they called it a dual discrete logarithm assumption, where it was impossible to find two discrete logarithms, blah, blah, blah. Nope, that was broken. Someone decided to do a proof of concept implementation, just try to move it forward. Nope, it was worthless. That assumption did not hold. So obviously there's varying degrees of assumptions, but if we're not introducing new ones and we're going through formal review, I'm more concerned about the implementation attack surface rather than the theoretical one.
I guess as a person who writes a lot of weird peer-reviewed papers, what is formal review to you? And specifically, does that apply to AGM as well?
Wait, you're getting up here. You guys are actually switching places soon.
So I actually stay out of the formal side of academia, so it's hard for me to comment. Hey, I just work here, okay? I'll write your code. I'm not going to build the next bulletproofs. Beyond, obviously, conference inclusion, which of course doesn't magically mean a paper is valid, but obviously is a great show of confidence in it. It does kind of become an ad hominem thing, where if there's developers I respect and trust who say, yes, I've reviewed this paper, yes, I didn't just skim the abstract, I read over it. But when you start having other developers review it, when other researchers chime in and say, yes, this is a valid proof, yeah, you believe it's a valid proof. So obviously it's about web of trust, but the easiest check mark for me is always just going to be conference inclusion.
I did hear one thing today, and this is secondhand, actually. But one of the challenges I heard today was that people were, because ZK proofs take quite a long time to prove, people are a little bit more risky on the encryption level that they'll do with them. So they'll just turn it down a little bit because it proves quicker. So that's maybe something we need to watch out for as well.
Okay,
I'll give you instant verification if you accept anything I say.
Guillermo, you're taking the middle seat. Thank you, Mr. Monero. To him. Oh, actually, yeah, to him.
Oh my, I'm up here now.
Can you answer your own question?
Did I answer my own
question?
Can you? Can I answer my own question? Oh, I certainly have thoughts about peer review in academia.
Oh, yeah.
Although I think we had some
about that.
at an episode, if I recall correctly. But that involved a lot of sake. So I guess if you want to hear the full thoughts, it probably involves at least one bottle of sake.
That's true.
That's an open invite for anyone. But anyways, more generally, yeah, peer review is kind of a weird thing that is unclear to me, and unfortunately, it's kind of the best thing we have as far as I know. But if someone comes up with something better, then an oh no. Oh,
Oh, no.
okay.
Okay.
Oh. But if anyone comes up with
We're,
something better,
we're
then
bringing the hair color back on stage.
Well, I mean, I just want to point out that we have an industry where like the product is the bug bounty.
This is true.
That's another alternative approach.
This is very
Adversarial.
true.
Henry, do you want to come back up? You could. No? Okay. Any other thoughts, questions, people who want to weigh in? This is the last session of the ZK Summit, so even if you had like thoughts from previous talks, just to sort of get that conversation going.
All right. So let's say you don't do math for fun, and you're at your first ZK Summit, and you've had that bottle of sake, and you're like, okay, I want to build stuff for users, and we know that ZK can scale. We know that ZK can make transactions be like worth microcents. What's the most important stuff in like the last 6 months or the future 6 months when it comes to new capabilities that allows you to build product for users that is awesome or is bullshit, in your opinion?
That's a great question. I don't think there's an opinion in there. I think that's a good question, right? It's pretty balanced.
I wasn't sure I understood what was the last part of the question? Sorry, could you repeat the very last part of it?
Not including scaling and like microcent transactions. What new capabilities of like current ZK tech that's showed up in the last 6 months, or you expect to show up in the next 6 months, has the most new, useful, and interesting capabilities to build user applications? Right. So
Sort
what
of
is
like
bullshit and what's not bullshit?
So it's like proposed use cases for ZK, basically, not scaling.
Yeah, or like.
I have an hot take on this. I think ZK can be very useful for compliance issues. Dan Bonnet actually talked about this a bit. Compliance is very important. Like, you can just submit a ZK proof and like do your taxes and stuff like that. And I'm very bullish on compliance. Scalability was very talked about today. Privacy as well. So compliance, I think, is my hot take. So,
I mean, I'm a bit biased, but I think our blue-haired fellow right here actually had probably one of the like craziest weird ideas where ZK is kind of used for something quite new, but it required creating new mechanisms. So specifically for things like shared, like very global state, things you can do with ZK are not obvious at all that you could do before. So I think that's a very cool application. And this is, I'm assuming by kind of like cheap transactions, you mean like you don't just use the asynchronous property of ZK, you actually use the ZK part of ZK. I think is a very, I don't know. Anyways, that's what I'm assuming that you mean by like cheapness or like easiness. Like you don't count that as part of the cool tech that's coming up. I think that is a cool one.
Yeah, probably a couple of things. Like I think this space is moving so fast that it's hard to keep up with all the new improvements. Like every couple of months, a new paper will come out with a new exciting idea that's kind of like making things faster. And I think if we can get ZK tech, there'll become an inflection point where ZK tech becomes so fast and so good that even from a scaling perspective, right, it just makes sense for it to be used. And I think the big thing that Web3 is missing in general is that usability layer. Like, I'm not going to use an app if it like takes 20 seconds to like submit a transaction, right? And so there is coming, and it is, whether it's 6 months, whether it's a year, it's coming, where you will use a dApp and you will barely notice. And that's where we've made it. And I think then a lot of useful things can be built on top of that.
I want to weigh in on this. So you said 6 months before, 6 months in the future. I feel like the ZK for compression was an idea for a long time, like clients. It's sort of in the scaling department, but it's like making something smaller. I think we've seen more implementations of that. What you talk about, at least the way I always understand, is like using ZK or other privacy tech in DeFi that actually allows for like either strategies to be really, really well masked, which is like, it's privacy, but it's like a very unique form of privacy, or where it actually kind of recreates the way that some of these things that you study work. Those are the things that seem very kind of new in that regard. I'm trying to think of it, like, because that's what you're looking for. You're thinking like ZK use cases, because I think you're talking more like ZK optimization, like it getting faster, but like you're saying what is possible what's becoming possible past scalability.
But I think if users don't use it, it's not possible to have like how many users don't use dApps because they're so slow. Like I feel like usability and speed is a feature at this point because it's like I'm giving you something so much faster. It's such a shift. And I understand what you're saying. That would just be my counterpoint, is that like I think it gets to the point where it makes a big difference.
I guess.
The bullshit. Oh, what's the bullshit? What's the most bullshit stuff in ZK? Ooh. Oh, that's so harsh.
Can I?
Oh. Wait, do you want to ask a question, or do you have some bullshit
actually,
in ZK?
I would have another question, if it's okay. Regarding security, how relevant do you consider like upcoming quantum computing solutions for like ZK, especially snarks?
So, I think this is more of a question about like quantum computing in general. I guess maybe I can weigh in on this one a little bit because I did work in a quantum computing lab for my PhD, unfortunately. But anyways, the answer is at the moment, exactly not relevant. Maybe over the next 20 years, probably slightly relevant. But it's shocking the progress that we have made. It is also equally shocking how extremely unsophisticated we are at doing essentially anything that is currently like truly quantum. In fact, there's been a whole set of things about like quantum supremacy and whether that has even existed, and some people have claimed it has, and then someone goes and writes like a algorithm, runs it on a supercomputer for like 2 days, and it's like, congratulations, we emulated your results. And this happens so often that the taste in my tongue that it leaves, and I've seen it in lab settings as well, is very much we're still 20 years away. What was said 20 years ago, and so we'll continue. But then again, we might say that about whatever fusion or something, but maybe at some point it'll actually happen. So I think that's the highest level version. We can get more into the details, but that would be, again, that might require the level of sake. So
one question: are you more confident in like lattice-based cryptography or hash-based snarks?
Oh, I actually don't know a lot about.
That's a real cryptography question.
Yeah, like actual cryptography. Unfortunately, I know very little.
All right. So any other? So I think that was a question. So thank you for the question. But so any other questions, comments? The way this always works, right? It's like the more opinionated, the more likely we're going to do a switch.
I do have a question. Can I ask the question to like everyone? Is that a cool thing to do?
Am I
inviting it?
So.
All right.
Wow.
This is like a different format.
You are hacking my format.
Sorry.
Go for it.
I mean, should we separate this is piggybacking on the previous question. Should we separate succinctness from like what we call zero knowledge, like as a whole? Like, is that a good thing to do? Like right now, we kind of, when we talk about zero knowledge, we mix in all of these things. Is that bad? Is that good? Is that, maybe Alex will have
one of the Alexes?
one question, one answer to this.
Do either of you want to answer that?
Yeah, I was kind of thinking about the answer.
And I guess one side comment is, can we do better by being just succinct and not zero knowledge? Do you know if there's a gap there? Do we know that there's a gap there, or maybe not? Maybe.
Well, I think Starks are by default just as succinct, not really zero knowledge. You have to do extra steps to make Stark zero knowledge. You have to go beyond the domain field. So it totally makes sense to separate.
And I guess why don't we? Maybe as an additional.
So I'll give my take quickly. I think like increasingly you're going to get systems that are tailored to the use case specifically. So I think where the way I like to think about zero knowledge systems is they conceal and they can compress, right? So compression is the succinctness piece. I think in like cases of rollups, right, you kind of, the zero knowledge is kind of an extra nice property that's maybe like, okay, you can verify that this is correct, but the privacy, the hiding piece isn't as important. And I think you're going to increase, because everyone is aiming for maximum performance, it's inevitably going to get to the point where you rip out everything that is not absolutely essential to the use case that you're serving. That's going to be the way that it goes. So I would predict that you see these systems start to branch off and just serve one or the other thing. So I think in some cases it could be good. It depends on the use case.
There was a question back there. Who had their hand up?
I think in Plunky 2 you can actually just specify you don't want zero knowledge in the configuration.
Does it actually help you though?
I think it's faster if you don't use it. Yeah.
Oh, it's actually like not just marginal.
Yeah. No, they actually say in their docs like, don't use it unless you need it.
Okay, that's actually I did not know this. All right.
Sorry, no. To add on to the point, I think it's actually in a way dangerous to not separate it, because I've heard people, founders actually, telling me they were doing this wonderful ZK app, and when I ask about the ZK, it's just because we are on this one ZK rollup. Like that was it. That was the whole ZK. So I think it is actually dangerous. And there's a third thing. It's not just the zero knowledge, the succinctness. There's also just the validity of what's going on. And that's a third axis that we have to sort of separate out.
I like that. I think you can come up. That sounds like opinionated.
You've been volunteered as tribute.
I think you're off. Thanks for being on the panel. Do you want to introduce yourself?
Yeah. Hi, I'm Nico, and I'm a cryptographer at Geometry.
We have a cryptographer here now, so we can ask all the cryptographer
Yeah, now you can ask the hard questions.
Alex is like, let me get out of here. Thanks for participating. Thank you for your awesome answers, questions. Okay, yeah, wait, you had a point, so I don't think that, do you want to ask a question?
No, it was just a point.
Okay. Does anyone else have any questions, comments, thoughts about what we've talked about already here, thoughts about talks that have happened? Things that you think this group might be able to answer. We do need some questions or this doesn't work, so yes. Sorry to push, but it's actually what I need.
Okay, so this question has to do with nomenclature, if you will. So as terms matter, do roll-ups, should you consider something a roll-up or an L2 if it has the ability on L1 for Ethereum to be able to immediately change that smart contract for upgradability? So should you, if they have the ability to stop those transactions from happening and from you being able to escape and force through transactions on L2, should they actually get that ability? I don't think they should, I guess is my opinion. They should have a separate classification based upon the ability to change their protocol to kind of freeze funds within their L2. So.
Yeah, from the way I see it, a rollup should just use execution off-chain and then use the main chain, layer 1, for security. And that's how I see it. I don't know if you want to add anything.
I mean, yeah, I feel this gets into the is a whale a fish or a mammal kind of question. It goes both ways. One feels like a much more useful classification, but the other one feels much more technically adept. So I don't know. I mean, upgradability of smart contracts from the L2 itself seem, yeah, it isn't. Maybe it's a useful distinction, but I would add it as a trademark after L2 as opposed to make a whole new nomenclature just for that.
If I can riff on the question, maybe for the panel that might be interesting is, there's a lot of discussion around where economic value will accrue in a world of L1s and L2s, right? So in your opinion, will the majority of the economic value accrue to the L1 upon which the L2 is built, or will it accrue to the L2, which could potentially serve multiple L1s?
Can you actually hold that? Because I want you to come up here.
Sorry.
And then can you ask that again? Yeah, please come up. Please come up.
Oh, you're right. You got to open it now. So.
Thank you for being on the panel, and welcome. Okay, you're gonna have to. So
I'll restate.
Actually, just quickly introduce yourself, and then Alex, if you can just.
Hello, I'm Brian. I am a grantee with the Ethereum Foundation. So.
Thanks.
So the question restated. In your opinion, between the L1 and the L2, in the L1 and L2 paradigm, does most economic value accrue to the L1 upon which L2s are built? Does most of the economic value accrue to L2s, which could potentially process transactions for multiple L1s? So that's the question. Where does the economic value accrue? I see Guillermo squirming, which is why I asked this question.
Do you want me to answer? Sure. So I guess my opinion, I think as we move forward into the future and onboard a ton of users, I think that we will see the value accrue to applications more than we will to the actual network. As much as I think the networks will actually continue to accrue value, I think that if we see true economic value of the real world come onto networks, I do think that they will hopefully surpass what's actually happening with the L1s. So I think L2s are going to take those applications and they're going to probably do whole L2s that are wrapped up in that one application, and I think they will see a ton of value accrue to them.
I actually think if it doesn't happen, if the applications don't get more valuable, then the project has failed.
Agreed.
Like the whole thing. Like it sort of has to.
Yeah.
It seems strange that we constantly just focus on Rails as the primary
But for the
economic
applications,
driver.
I mean, applications to be secure, there needs to be economic value at some level, right? Where you're settling, certainly like in a financial application, where it's settled. This is the idea of Ethereum, right? Is why it's secure is because the miners have this huge economic incentive to play by the rules. That's the whole premise. So I guess that's the. I agree. So great. First of all, great dodge of the question that the application should be the one. But
yeah, like the problem with this question is that. And I feel this way about a lot of weird economic questions, is that the kind of silly thing to say feels right, but it's probably totally wrong, and we'll have no idea until it actually happens. So you know, like we can talk about like weird supply and demand curves and being like, oh, like of course, like the thing that should, you know, that everything is running on should have at least as much value as the things that are running on it. And that feels like a totally sensible argument. But my suspicion is that it's completely wrong, and we'll have no idea why. And then someone will make some horrible model, you know, 5 years from now and be like, oh, of course, it was like obvious. And everyone should have known that was not the case, that the L1s would indeed accrue as much, or not accrue as much value as the L2s that are sitting on it or something. So I will dodge the question as well, but I will do it with something that sounds intelligent, which is we have no idea, and in fact, I don't think we'll have an idea. But it's going to be really fun 5 years from now to be like, to write some paper that says, obviously, we should have known ahead of time that indeed, and it's going to be peer reviewed, and everyone's going to be like, oh, yeah, it was obvious, you know, reviewer 2 is going to tell you, sorry, I rejected it because this should have been stupid. You know, we all did know that back in, whatever, 2022 or something.
I have one final hope to have my question answered, but...
No hope. I'm also going to dodge that. Like,
it's gone.
What do we mean by value, right? Is it just the gas fees that we're spending on different layers, or is it something we charge users for a service? Other than just computation, right?
That's a good question.
And I don't know at all.
This panel is just an expert question dodging. Like, reframe the whole paradigm, like
here.
completely
redirects us to ask questions.
So I do want to. Oh, okay, so because there is another question, so I wasn't sure if we should wrap up now or after. So Alex,
yes.
I think you're up.
Oh, me?
You're taking Guillermo. Guillermo, if you don't mind being the mic person, and there's a question right there. Thank you, Guillermo. No, I think he had it. Yeah, he had a question.
Oh.
I didn't actually have a question, I had a comment. And the comment was not actually going to answer the question, it's also going to dodge the question.
Serious?
I think the value, if we get it right, will be actually for the users of these platforms, right? Like, ideally, if you can have like a system where you own the data and it's all privacy, so you have it and you can prove stuff about your information, then all of your information and that value goes back to you, right? And so actually a lot of these economic systems will eventually just kind of be very competitive in terms of like competition in terms of providing the service, whereas the users hold the key to all the data. Anyway, sorry, not answering your question.
So the TLDR is, like anyone who saw Ariel's talk earlier today is, I don't know.
Wait, Alex, why don't you answer the question?
What's my my own answer?
Question, yeah.
I think so my own answer is I think anything that supports applications that people will use or use it in the way that we think of Web3, wherein we have this economic incentive at the base layer, that will be what accrues value. I think the L1, L2 framing is wrong because I think there's a potential that things we think of as L2s today could serve multiple networks and then kind of over time transform and become some root layer. But I think there will always be this root of trust. And I think, again, in this paradigm which you've all accepted, where this game theory and the economic security model, I mean, if we don't have that economic security model, you don't really have a blockchain, in my opinion, right? I mean, I don't know. I mean, maybe that's a more fundamental question. Is a blockchain a blockchain without an economic security model?
Twist. Did you want to say anything more? Because I'm going to bring him back up.
No, I was going to say, like, I'm hearing dodging your own question. Like, these
dodged my own
L2s becoming L1s
okay,
and confused.
You're up here. And thank you for being on the stage. And you've already been here, so you don't have to introduce yourself again. And I know there's a new question here,
yes.
Or comment, or dodge. Ball is what we're playing now, I guess. Okay.
Just a question. So I'm wondering, do you think like the succinctness of validity rollups or enshrined rollups is like the only end game for blockchains and distributed ledger technology, or like if you want to build 1 billion user application, or can you actually build these applications on like Solana or Cosmos or other sort of scaling solutions?
No. I think the architecture for existing blockchains, of course, sharding will help, but you're just taking an architecture and making more of it, I think is not the right way to go personally. I think rollups are able, and if particularly, I can't remember who it was here, maybe it was you who were doing these like micro rollups.
Oh yeah. So with that Alio, every transaction you could think of, effectively.
Right, and I think like taking that data and doing these smaller rollups is actually the way to go, and that's something that we're looking to implement as well in our decentralized database, is to have the ability to basically split the data out, and because you've got a ZK proof, you can actually take data from one place and prove it in another place very easily, so you don't need to have this conglomerate global hash that just lives, right? You can actually, prove any piece of information anywhere else. And I think that's the future of scaling, and a lot more computation, because Snarks will enable us to do all the computation, or a lot of the computation on the client side. Actually, what these blockchains will become is verification networks. And all of the data will be owned by you. There may be some level of data that exists on the network because you're not online all the time, your phone's not online all the time. But fundamentally, yes, we do need to re-architect the way that we do.
Yeah, I agree with that. I think that was very well said, and I think answering without dodging, I think the answer is yes. This is the model, and in fact, I think you've seen this this whole concept of rollups has kind of expanded to this concept of a modular blockchain, and really even at a more fundamental level, it's separating execution from state storage and separating all the different parts from each other, right? And this is one of the reasons why I think if you look at a lot of these Snark-based systems, the key bottlenecks are often how big is the proof, right, for a decentralized, because a decentralized system, every node has to store the whole chain, right? So this is like how big is the proof, and is there an ability to recursively prove it down to be very small? But even if there is, that's fine for clients, but somewhere, someone has to store that state, right? So the state is one part of it, but then the execution, because you're proving off-chain, it actually opens up this amazing new dimension for applications, right? If you're not limited by the runtime of like an EVM, you could run a program for 50 years, spit a proof out at the end, and have the network verified. And that's something you can't do on Ethereum, right, today. That's like a fundamentally new model, which is cool. But the bottleneck becomes verification time. And this is one of the reasons why we talked a little bit earlier about Snarks versus IPAs or Starks. This is one of the reasons why, despite all these really new interesting proof systems, Snarks have remained the tool of choice because the verification time is cheap and the size of the proof is constant, no matter how large the computation grows.
Do you think, was that a question or a comment?
Me?
No, his. I was kind of in the middle, I wasn't sure. Actually, the question here is, are there more questions, comments? Because if there aren't, then we'll wrap. But if there are, then we'll continue.
Can I just give someone time to think of another question? Maybe just add on to the end of that?
Sure. You guys
I think there's going to be an absolutely huge opportunity as well. If you think about how big an industry cloud computing is, I don't think people realize that, right? Cloud computing is massive. And if you took all of that computation that happens on the cloud and you put it onto the client, that's a lot of value now going to the client. And that's just going to be super interesting.
Okay, in that case, you are coming up. Let's get some new faces.
Yeah. You're coming up. Sorry.
No, thanks for coming up. Do you want to introduce yourself?
Hi, my name is Philip. I work as a research associate at a venture capital firm called Rockaway, based in Prague.
Cool. Welcome. Are there any other? Okay, there's a question over here.
Hey, can you hear me?
Yep.
A little bit of an opinionated question, but going back to the one that everyone dodged about where would value accrue. Curious to hear, do you think where value will accrue will change depending on your time scale? So 1 year out versus 3 years versus 5 years versus 10 years. Do you think 10 years from now it'll be application level, but 5 years it'll be L1, 3 years it'll be L2? Do we think that may be a better mental model? Do you think it will change over time like that?
I can hear you trying to put comment in there. But it's a good question.
I'll take a stab since I articulated the original dodged question, which I myself dodged. I think it will absolutely change. I think it'll change based on what parts of the system become less or more expensive over time, and there's a lot of factors there, right? So I mean, technological improvements. I mean, if you think about Moore's law, like just Moore's law and what that's enabled over time for computing, I mean, that's made certain things that used to be extremely expensive commodities that everyone just assumes are free now, right? And I think you could, the same thing with storage, right? As we've all gotten used to having, terabytes, on our laptops around, which is like before, like terabytes were, that concept was extremely expensive. So I think as the hardware kind of matures, I think different things are going to be viewed as cheaper, but of course there's a market. I think the market will also determine for different applications, like whether storage or like state growth or maintaining state with some reasonable degree of retrieval latency is more important than executing something. So I think it depends on the time scale, but also it depends on the application.
Can I add something on that?
Before you do that, I want to switch out.
Okay.
So, do you want to come up? I feel like there's more questions. I saw some other hands, so that's good. Okay. Actually, wait. He's going to introduce himself. You have to wait for him to get here.
Hey guys, I'm Matt. I'm building private multisigs on Aztec and Alio.
Cool.
Yeah, so I actually think the economic model is going to change completely. Like today, we think about companies in a very different way, and I think the future of Web3 companies is going to be completely different. So today, as a company, you build a product, for example, and then you get monthly or yearly annual profits from that, and that goes basically back to the shareholders who put in some money at the beginning. And I think actually what we're seeing with DAOs that have been created and around protocols is actually you take the value at the beginning, so you tie the value proposition of your protocol to your coin, and so the more usage your protocol gets, the more the coin goes up. So all your initial investors get returned once in a big amount, a big chunk of money, they get returned. And so that's great, they're done. And then we can use the rest of the kind of economic system can actually balance itself and not be as much for profit anymore. So
I mean, this is the dream.
Yeah, I mean, that's the dream.
I think there's a lot of other stuff happening that pushes those prices around than utility, if you look at the top 10.
And actually if you look at most protocols, there's no reason why the price of the coin should go up based on what's happening on the protocol. And you can build that in. There is economic systems to build that in. And the Graph is one of the people who are doing it right, and they actually have a system whereby it's called the utility token model, and you can basically tie, using a kind of taxi medallion type methodology, you can basically say, okay, if you want to make money on our platform, you have to stake some amount of money, and then that makes it work.
Mm-hmm. Any other thoughts, questions, comments? We're kind of at time. Maybe one last one?
I did have one comment on that.
Okay, yeah, or we take it from here. Go for it.
My opinion is actually more in Guille's camp about you never really know, and it's going to be a complete up in the air thing that we'll look back on and be like, oh, that made sense. But I do think it'll be, like, there's so many different ways that it can go that wave function will collapse, and everyone will be like, oh, of course it went down that path. But, like, Cisco was, during the initial internet build-out, was the most valuable company, worth $500 billion at one point, that everyone just projected that, oh, that one's going to be the one, and they're going to charge the most, and that wave function never collapsed until it did. And then it went down 80%, and Facebook became the most.
I think that's a good point to end this on. We don't know. We don't know anything. Zero knowledge. All right. Thanks, everyone, for the Park Bench panel. It was a lot of fun. I believe we have another slide we can maybe put up, which is our last slide. I don't know if you have this. Maybe you do, maybe you don't. I don't know if you do. Yes. Okay, so we are now going downstairs. There are drinks. I can say that correctly. And Least Authority has a special kind of gift drink that you should definitely check out. They have there's like a textbook called the Moon Math Manual. I don't know if you've heard of it. It was in the Gitcoin rounds. I think I've mentioned it on the show in the sponsorship spots. But yeah, you should go check it out because it's connected to that. This is like a ZK tech textbook that we've been waiting for that's at least like a first, they're starting to come out. It's not the only one, but it's really, really cool that they're doing that. So please enjoy the drinks, and thank you all again for coming to the ZK Summit 8. See you at the next one, I guess, right?